Welcome back everyone. In this section, we are going to look into anatomy of blockchain. In the previous section, we have learned what blockchain is, what are the types of network, what are the components, use cases, and couple of examples of blockchain. In this session, we are going to look into blockchain structure, blockchain lifecycle, smart contract, different types of consensus algorithm, who are the players in the blockchain, and couple of other details which are related to players in the blockchain. Now let us understand how blockchain works. So blockchain technology is a peer-to-peer distributed ledger that can record all transactions of two peers or two parties securely and efficiently. These transactions are stored inside blocks. Blocks are linked to form a chain. The creation of block is done through a process of consensus in peer-to-peer network where peers work simultaneously to solve a complex mathematical problem to validate the block. Once the block is added to blockchain, you cannot change it. Even if you try to change it, it is easy to verify that it is not a valid data. This is the main reason why blockchain is secure. In this slide, you can see how blocks are stored in the blockchain. As you can see, these are considered as block, which is uniquely numbered. As you can see, block 10, block 11, block 12, and the chain continues. So as you can see, every block contains different fields. As you can see, previous hash, timestamp, transaction root, nonce. So these are the different fields that are present in block. One interesting field is the transaction root, which is also called Merkle hash root. Now let us see what Merkle root is. Before that, let us understand what Merkle tree is, or Merkle data tree, or Merkle hash tree, whatever we call. So let us see what is that. So Merkle tree is a data structure and it's nothing but a binary hash tree. Merkle tree stores the hashes of individual data or individual transaction in a tree structure, which makes the verification of dataset or transaction efficient. Merkle tree summarizes all the transaction in a block, producing an overall digital fingerprint of an entire set of transactions. Because of Merkle tree, you can easily verify whether a transaction is part of the blockchain or not. So when you have, let's go to the previous slide. So as you can see here, the transaction root, this transaction root contains all the transactional hash of main. So as you can see, let me explain it clearly. So you have four transactions and each of the transaction is hashed to a particular hashing value, and they are combined, and the combined value hashed value will be present in the transaction root. So with this, you can easily verify whether a particular transaction, for example, transaction 1 is part of this block or not. So that is the advantage of Merkle hash tree. The lifecycle transaction differs from one blockchain to another blockchain. For example, life cycle of a transaction on Hyperledger Fabric is different than life cycle of a transaction in Bitcoin. Now let us see what is the life cycle of transaction on Hyperledger Fabric. So in the left side picture, as you can see, there's something called MSP. So we're going to learn what MSP shortly. So MSP is nothing but the membership service provider that enrolls the user and application to the blockchain network. After the enrollment, the application submits the transaction proposal to endorsing peers. Endorsing peers simulates the transaction and responds back to the application. Application then submits the transaction to the orderer. Orderer sorts the transaction, assembles the block, and sends to the committing peer. So committing peer validates the transaction and updates the ledger. So this is the simple way of explaining how transaction works in Hyperledger Fabric. As we move forward in this course, you will understand the detailed process. As I've told before, the life cycle of a transaction differs from one blockchain to another. Let us see the Bitcoin transaction life cycle. So the life cycle of a transaction on Bitcoin is is basically transferring the currency from one account to another. So, as you already know, Bitcoin is a currency transfer platform. A peer initiates the transaction, and once he initiates the transaction, he enters the destination Bitcoin address, and he also enters the amount that he wants to transfer to the destination Bitcoin address. After that, he authorizes the payment using the private key, his own private key. Then this transaction will get validated by miners, and miners are nothing but the peers in the network. So miners who solve the proof of work problem propagates propagates the new block to the network, and other miners verify the new block, and the payment will be sent to the destination address. So this is in short how the transaction works in Bitcoin blockchain. Now let us understand what is smart contracts. So smart contract is a computer code running on blockchain network. It contains a set of rules under which both parties have agreed upon. When these rules are met, the agreement or the smart contract will get automatically executed. So smart contract between two parties is mainly for transferring digital assets in the network. Now, since we understood the definition of smart contract, now let us understand how smart contract works. So this is a pictorial representation of how smart contract works. So in the first step, the smart contract is written as code into the blockchain network. In step 2, when certain event occurs, the smart contract code will get automatically executed. In step 3, which will lead to transfer of assets from one party to another party in the network. In step 4, since this transaction is stored in the immutable data structure which is blockchain, any regulator can verify the transaction. So this is in a nutshell how smart contract works. Now let us see what a consensus algorithm. So in order for the network to decide which transaction should form a block and where it should be placed in blockchain, the consensus algorithm should be in place. Consensus algorithms are designed to achieve reliability in a network involving multiple rules. So there are different types of consensus algorithm. Couple of them are listed here, which are proof of work, proof of stake, practical Byzantine fault tolerance. So proof of work. So proof of work is a system that is used to process blocks of transaction and add them to the blockchain. So here a term, what do you mean by mining? So there is a term called mining. So what do you mean by mining is, so mining is a process of generating correct proofs in order to add a block to the blockchain. And individuals that participates in the mining process are called miners. So proof of work was first used by Bitcoin blockchain system. So proof of work requires miners to solve complex cryptographic puzzles before they can add a block to the blockchain. In exchange for solving this puzzle, the miners get rewarded with Bitcoin. So this is what proof of work is. And when it comes to proof of stake is a system where miners or peers that are chosen to generate the block, and these miners are called validators. So you may ask yourself, who can be a validator? How these validators are chosen in the system? In proof of stake system, validators are chosen to generate a new block based on their economic stake in the network. So if you have higher stake, you have a higher chance of becoming a validator. So what is Byzantine fault tolerance? So before getting to know what Byzantine fault tolerance, please familiarize yourself with what Byzantine problem is. So, in order to tackle Byzantine problem, we came across with Byzantine fault tolerance. So, fault tolerance is the ability of distributed computer network to function as desired and correctly to reach a sufficient consensus despite of malicious nodes in the system who tries to propagate incorrect information to other peers in the network. The main objective is to defend against any catastrophic system failure by mitigating the influence of malicious nodes who are propagating incorrect information. As a result, we can reach the right consensus by honest nodes sending the right information. So this is what Byzantine fault tolerance is. Now, who are the players in blockchain? So there are different players in blockchain and couple of them are listed here. So blockchain architect will be responsible for architecting and designing the blockchain solution. Blockchain developer is responsible for writing the application smart contract that interacts with the blockchain and are used by the blockchain users. So blockchain user is a business user operating in the business network. This role interacts with the blockchain using an application which is written by blockchain developer, and they are not aware of the blockchain, meaning they are just end users. Blockchain regulator. The overall authority in a business network, specifically regulators may require broad access to ledger content. Then you have blockchain operator. So they monitor the blockchain network. Each business in the network has a blockchain network operator. You have membership services where it manages different types of certificates required to run a permissioned blockchain. You also have different systems like traditional processing platform and traditional data source where you need to interact blockchain network with the other third party platform or data source as well. So you might have heard of distributed application, which is also called as dApps. So dApps are nothing but your front end code and also your contracts written on the network. So if you can see, distributed application code can have their own front end, distributed front end as well, and you have different applications or different decentralized storage such as Swarm and IPVFS, where you can host this distributed storage or decentralized storage. So you can also make different components of the dApp distributed as well. For example, you can make front end distributed and you already have the smart contracts distributed as well. So your distributed application is nothing but the front end and also the smart contracts. That is it for this lecture. In the next lecture, we'll get into what Hyperledger is, the family introduction of Hyperledger, the design philosophy behind Hyperledger, the architecture on which Hyperledger built on, and things like that. So that is it for this lecture. Please do subscribe for our private coaching sessions as well. I'll see you in the next section. Thank you for watching.